Welcome to our celestial expedition into one of astronomy's most enduring questions. How did our moon come to be? Today, we'll explore 4 key theories proposed by scientists over the years, each with its unique insights and challenges. Let's start with the Fission theory. Proposed by George Darwin, this theory suggests that the moon was once part of Earth. According to this hypothesis, the moon separated from Earth in its early development stage, when Earth's rotation was much faster than today. The theory implies that a location like the Pacific Ocean could be where this separation occurred. Similarities in the composition of Earth's crust and the moon's surface, as well as in their mineral compositions, make this theory intriguing. However, questions about differences in isotopic compositions and challenges in explaining the angular momentum of Earth and Moon create skepticism towards this theory. Moreover, technological advancements and detailed analyses of lunar rocks have led to this theory being considered less likely. Next is the capture theory, offering a different perspective on the moon's formation, suggesting it was originally an independent body that was later captured by Earth's gravity. This theory explains the differences in isotopic composition between Earth and the moon, challenging to reconcile with other theories. According to this idea, the moon could have originated from another part of the solar system, possibly explaining some of its unique characteristics. However, the dynamics of capturing a large body like the moon presents a significant challenge. How did the moon slow down enough for Earth to capture it? Additionally, the similarity in oxygen isotopes between Earth and the moon raises further questions, making this theory less accepted among scientists. The co-formation theory suggests that Earth and the moon originated together from the same cloud of dust and gas that surrounded the Sun. Aligned with the general understanding of planetary formation, this theory presumes Earth and the moon shared the same material source, explaining some of their similarities. Studying the composition of lunar rocks, certain similarities have been found that could support this theory. Yet there are significant challenges, differences in isotopic signatures between Earth and the moon, and questions related to the moon's unique angular momentum remain key issues. The theory also struggles to explain why the moon has a lower metal content compared to Earth, which would be expected to be more similar if both bodies originated from the same material. The giant impact hypothesis, currently the most accepted theory of moon formation, describes a dramatic event where a Mars-sized body known as Theia collided with Earth. This collision ejected a vast amount of material into orbit around Earth, which later formed the moon. This hypothesis explains many of the moon's unique features, including its orbit and composition. Evidence from rock samples from the Apollo missions and computer simulations strongly support this theory. However, challenges remain. The precise composition of Theia and the specific conditions required for such a collision are still subjects of debate. Additionally, there is the question of how the ejected material formed the moon with its specific characteristics. Each of these theories brings its unique ideas and challenges to the puzzle of the moon's origin. While the giant impact hypothesis is currently the most accepted, the quest for a complete understanding of the moon's origins continues. Thank you for joining us on this cosmic adventure. The moon, a symbol of mystery and admiration, reminds us of the importance of exploration and the endless human curiosity. Which theory do you find most credible? Do you have your theory about the moon's formation? Share your answers in the comments. And don't forget to like and subscribe.